Nonlinear model selection in Navure 3.0. With version 2.5, Navure introduced the ability to incorporate factors into nonlinear models. Now, with version 3, we have enhanced this feature by enabling model selection. This new feature automatically merges factor levels to create a simplified model when appropriate. Let's see this feature in action by analyzing the cumulative biomass production of a pasture under 3 management regimes. Open the Growing Pastures dataset in the Testing File repository. The table has 4 columns: treatment, plot, time, and growth. We will fit a logistic model to growth as a function of time, considering that the observations come from 3 different treatments and the plots were sampled at 9 time points. To proceed, click the Univariate tab, then click the Nonlinear Mixed Model button. In the pop-up window, drag growth into the response variable box. Next, drag treatment and plot to the fixed and random factors box, then drag time to the covariate box. Finally, click the OK. A pop-up window is displayed. Because a unique covariate was included, it is already selected on the list on the right of the window. With the unique covariate selected, you can choose one of the predefined nonlinear models from a pop-up list, or you can write your own model as well. Let's choose the logistic model. When done, starting values are assigned using a clever algorithm, but as always, you can change them. Now we want to include treatment factors. Instead of having to specify dummy variables and create a complex formula to include them, just click the treatment factors item on the left. Then double-click on treatment on the list at right. The list of parameters in the model will be displayed, waiting for you to decide which parameters the treatments will affect. We choose all of them. Specifying a factor effect generates a model for each treatment level. In other words, different models are simultaneously fitted for each factor level. To reduce model complexity, you can merge factor levels. Then, you can test whether this results in a better model according to the Alkaika Information Criterion, AIC, or the Bayesian Information Criterion, BC. This is the purpose of the collapse level option at the bottom of the factors panel. We chose AIC. To account for the plot effect, we will treat it as a random factor. Due to a convergence issue, however, we can only include a random effect on the alpha parameter in this example. Finally, click OK to proceed. While we wait for the results, note that we can include additional settings, such as a correlation function to account for autocorrelation or a variance function to model heteroscedasticity. There are several points to highlight in the output. First, the algorithm determined that merging levels B and C is preferable to using different models for each level. Second, a simplified version of the fitter model is displayed, along with a reference to the elements in the model. Third, the standard output for the simplified model is shown, along with formulas for treatment A and the combination of levels B and C. Lastly, the 2 fitted models are displayed graphically. Don't forget to update your software and explore these new tools. If you have any questions or feedback, feel free to reach out. Thank you for your attention.